Hello all, I am Rajaneesh Chandran, Assistant Professor in the Department of Mechanical Engineering of Marine Engineering College. Welcome to my YouTube channel where we can learn different engineering subjects. So in this particular video, we are going to study about the concept of projection in engineering graphics. So we know that engineering graphics is a language for communication between engineers with the help of various sketches and images. The basic thing in engineering graphics is the concept of projection. See, now you can see a rectangular block which have a length, breadth and a depth, or a length, breadth and a height. So this is a three-dimensional object and we have to draw or represent this three-dimensional object onto a two-dimensional plane. Two-dimensional plane means our blackboard or the piece of paper we are having, where we have to represent this three-dimensional object. So how this three-dimensional object can be represented onto a two-dimensional plane? That we are doing using projection. So what is projection? So basically projection is the representation of an image which is formed by some visual rays on a plane which is called a picture plane. So depending upon the orientation of the object, location of the observer or the point of sight, and according to the visual rays, direction of the visual rays with respect to the plane, different projections can be formed like a parallel projection, orthographic projection, perspective projection, axonometric projection and oblique projection. And in this particular video we are learning orthographic projection. So orthographic projection means the visual rays coming from the eye of the observer will be parallel to the ground, because in orthographic projection the observer is considered to be placed at infinity. So when the observer is at infinity, the visual rays coming from the eye of the observer will be parallel to the ground. And in also orthographic projection, the picture plane will always perpendicular to the visual rays. So in orthographic projection, there will be a picture plane that will be perpendicular to the visual rays coming from the eye of the observer. So when the observer's eye, it is also known as a station point. So when the observer is at infinity, the visual rays coming from the eye of the observer will be parallel to the ground or parallel to each other, and that visual rays will be perpendicular to the picture plane. So such a projection is known as a orthographic projection, and in this video we are going to study about orthographic projection. Okay. So I have already told that the method of projection is used for representing any three-dimensional object onto a two-dimensional plane. See, this is a rectangular block. So how can this rectangular block can be represented on a two-dimensional plane by the method of projection? See, the method is, we know that this is a three-dimensional object and we cannot represent this three-dimensional object as this in a two-dimensional plane. So we will observe this object from its front, from its back, from its top, from its bottom, from the left side and from the right side, and also the observer should be at infinity. So when we are observing this object from the 6 different places at infinity, we can see the corresponding two-dimensional images. That two-dimensional images can be drawn onto the board, so that one who know how to read these 6 images using the method of projection can understand that this is the projection of a rectangular block, 6 projections of a rectangular block. I will explain again. When the observer is placed at an infinite distance and when he observes this object from the front, what he can see? He can see this object as a rectangle, right? He can see or he can observe this object as a rectangle, so that he can draw a rectangle like this. he can draw a rectangle like this, and on the below he can write this as a front. Clear? Similarly, that observer can be observed from the back. See, this is its back. In that position also he can see the rectangle, so he can draw another rectangle and he can write it as back. Similarly, he can observe this from its top. Again he can see a rectangle. He can observe on the bottom, he can see a rectangle. So he will get another rectangle, that is the top view. Also he will get another, that is bottom view. When he observes from its left side, this is its left side, he can see this rectangle. When he observes from right side, he can see this rectangle. So this is left side view and this is right side. The important thing is, see, when you are observing this rectangular object from a finite distance, you can see this portion as well as you can see some portions of this side, some portions of this side. You may see this portion, some portions of this side or this side. Why? Because you are observing from a finite distance, right? See, now I can see this point. Here also I can see some portions of this side, some portions of this side also I can see. Why? Because I am observing this object from a finite distance, right? But when you are observing this object from an infinite distance, you can only see this portion. That is what I told earlier, is orthographic projection. In orthographic projection, the observer is placed at infinity. So when the observer is at infinity, the visual rays coming from the eye of the observer will be parallel to the ground and parallel to each other, so that the rays can pierce through this point, through this point, through this point and this point, so that only he can see this rectangle. He cannot see these other portions. That's the difference in orthographic projection. Okay, that's how he can see only these portions. So I hope all of you have understood these 6 images. Now listen. This is the front view, this is the back view, this is the top view, bottom view, left side view and the right side. So with the help of these 6 images, anyone who know how to project an object can understand that this is the 6 views of a rectangular block, or this is the orthographic projections or projections of a rectangular block, right? Now, see, this is the front view and this is back view, right? Suppose this is a rectangular block, and if this is a trapezoid like this, trapezoidal block, this rectangle and the back rectangle will be of different size, right? So that this will be of slightly less size as compared to this. Now, if we are able to know the front and back view, or if we are able to draw the front and back view together in a single view like this. See, this is the front view. I have told if this is a trapezoidal block, the back view will be lesser size as compared to the front view. Suppose now I am drawing a projection of a trapezoidal block. So this length and this length will be having some difference. So when the observer is observing from its front, there will be a rectangle. Similarly, when he is observing from the back, there will be another rectangle, but of a different size. That means the front view can be drawn like this, with a small difference in size. The back view can be drawn like this. Clear? So this is the front view and this is the back view. So when we draw the front view, we have to write it as a front view, and when we draw the back view, we have to write it as a back view. But if we can able to combine both the front and back view, we can draw this as together like this, so that here we can write it as front and back. Clear? See, this is the front view and this is the back view, and we have combined it together. Combined and draw it together, so that this is the front and back view. Now, how can we differentiate which one is front and which one is back? See, here we use the yellow color for the front view and red color or pink color for the back view, right? In that manner, we can differentiate the front as well as the back view. So, here we have used the yellow color for the front view and the back pink color for the back view, right? See, when the observer is observing this object from the front, he can see the front view like this, and he can see the back view here. See, when the observer is at its front, actually this portion back is invisible to him, right? So, if we are able to draw the visible and invisible edge with some differentiation, then we can combine this front and back view as a single one like this. Here we use a yellow color for the front view and a pink color for the back view, right? But actually in engineering graphics, what we are using is, or what we are doing is, we can use different types of lines for different types of views. See, here the front view is drawn with yellow, and here it is pink. But in actual practice in engineering graphics, we can utilize different types of lines that we will learn later. So, if we use, or if we draw with a thick line, we can say that it is a front view or it is a border. And if this is a dotted line, we can see that we can say that this is an invisible edge. Okay, that we will study later. You just remember these things, so that by utilizing different types lines, we can combine this front and back view together. Similarly, we can combine this top and front view together. So, this is top and bottom view together, and also left and right side, so that these six images are now reduced to 3 images, right? Initially there was 6 images, but we combined front and back, top and bottom, as well as left side and or both the side views together, so that these 6 views are now reduced to 3 views, so that we can differentiate it. This is a part of front view and this is a part of back view. This is a part of top view, this is a part of bottom view, this is left and this is right. How? Because we use different color lines, right? Similarly, we can utilize different type lines for differentiating these front and back, top and bottom, or left side and the right side, or visible and invisible edges, that we will study later. So, now the 6 images are reduced to 3 images. This is front and back view, this is top and bottom, and this is the side views, right? See here, this is an image, and on the bottom or the below we have written as front and back. Similarly, this is top and bottom, and this is side view. Suppose in a sheet or in a particular place, if there is a particular space for this front view and back view, if there is a particular position for drawing this top and bottom as well as for side view, then this front and back view, this front and back view, this word top, bottom, this word left side and right side can be removed, so that only the sketches will be there in the image, right? See, if there is a particular position on the screen or the blackboard or the sheet, then this description can be removed, so that we can draw like this. See what happened now. The front and top view, the front and back view, the top and bottom view and the side view are drawn on the sheet, but the description is removed. Why? Because if we can draw this projection like this, and if there is a particular position or particular point where only the front and back view is drawn, only the top and bottom, or only the left side and right side, then the description can be removed. See, in the earlier image we have drawn the image and we have described it as a front and top, front and bottom, front and back, top and bottom, like that. But now the description is removed, and see, there is a, in this point only the front or back view is drawn. Here only the top or bottom, only the top or bottom, only the side views given or drawn. Such method is known as a projection. So that I have drawn like this, another person, he is checking this image, also know how to project an object. Then only he can understood that this is the projection of a trapezoidal block. Okay. So this is the front view and this is the top view, right? There is a line between this. If this line is not there, this together will be part of the front view or will be part of the top view. So there is a line which differentiates this front view with the top view, and this line is known as a reference line or XY line, so that on the top of that line we can take it as a front view, on the bottom of that line we can take it as a top view, and there is a vertical line on the left side we can take it as a side view. Here also we can draw the side view. If we are looking from this side, left side will be here, and if you are observing from this side, left side, right side will be, side view will be projected here. That we will later. So this is the method of projection of an object, so that with the help of this image we can say that this is the projection of a trapezoidal block. That is the method of projection in engineering graphics. Now I have told a new term, an XY line. What is that XY line? This XY line differentiates the front view and the top view. Right. Now, what is the front view? What is the top view? I will explain again. So now we have constructed the three views of a trapezoidal block. This is the front view, this is the top view, and this is the side view. Actually, there was a small mistake while constructing the side view of the trapezoidal block. Actually, in the side view it will be visible as a trapezoid. So this is the corrected image. So this is the front view, this is the top view, and this is the side view. So we have plotted the front view, top view, and side view. But how we achieved these three views? Also, I have mentioned about picture planes, right? See, in engineering graphics, there are three planes known as vertical plane or VP, horizontal plane or HP, and there is also a side plane or profile plane PP. Horizontal plane is the plane which is parallel to the ground. Vertical plane is the plane which is perpendicular to the ground, and side plane is the plane parallel to the side plane, or perpendicular to both HP and both VP. Also, this vertical plane is perpendicular to ground or perpendicular to HP and also having infinite length. It extends in this direction as well as in this direction, so it have a infinite length. Similarly, the horizontal plane also extends in this direction having infinite length, in this direction as well as in this direction. So the horizontal plane will be parallel to the ground and the vertical plane will be perpendicular to the ground. Clear? Also, when the observer is observing the object from its front, that projection will be projected in the VP. So the front view will be projected in the VP. Similarly, the top view will be projected in the SP. So the front view will be projected in the VP and the top view will be projected in the VP. But also there is a problem. What is the problem? See, both the planes have different orientation, 90-degree orientation, right? See, this is lying in this plane, this is lying in this plane. So how can we draw these two 90-degree planes in a single line or single two-dimensional plane? See, this plane is lying in this direction, this plane is lying in this direction. We obtain the front view here, top view here. How can we draw this front view and top view in a single image or in a single plane? See, if we are placing or if we are taking these two planes like this, we cannot draw these images together in a single plane, right? So what will be the rule? The rule is keep the vertical plane stationary and rotate the horizontal plane in the clockwise direction like this and make align this vertical plane with the horizontal plane. See, initially this was like this. So keep the vertical plane fixed, rotate the horizontal plane clockwise direction and make align it with the vertical plane, so that now this entire HP, both VP and HP lie in a single plane. So we can easily say that this is the front view or this is the image on the vertical plane and this is the image on the horizontal plane, right? But there is also a problem. What is the problem? See, now this is a single plane. So how can we differentiate this vertical plane with the horizontal plane? For that, see, there is a line. This line is known as XY line or reference line. That line differentiate this horizontal plane with the vertical plane, similar to this one. So if we can see this horizontal reference line on the top of it, we can say that it is a part of VP, and on the below portion we can say that it is a part of HP. In that manner, the images which placed on the VP as well as on the HP can be differentiated. So this is a reference line. On the top of the reference line there is VP, and on the bottom of the reference line there is HP. This is not a common rule. For this particular portion, for this particular image, the portion above this reference line, this is the front view, this is the top view, so this can be taken as a vertical plane, this can be taken as a horizontal plane. Is it clear? So this is the method for projecting an object onto a two-dimensional plane. Actually, there are two types of projections: first angle projection and third angle projection. What is the difference between first angle projection and third angle projection is, in the first angle projection, the top view will be in the front view will be above the XY line, the top view will be below the XY line, and the side view, when we are looking from the left side, or the left side view will be coming on the right side, or the right side view will be coming on the left side. That is the first angle projection. Now the front view will be on, if the front view is on the bottom side, if the top view is on the top side, if the left side view is on the left side, right side view is on the right side, that is called a third angle projection. The difference you can see now in your screen right now. In our country, we are following first angle projection. So these are the basic things related to projection. So I will explain again. There are three planes. One is a horizontal plane, another one is vertical plane, and another one is a side plane. So the front view will always be projected on the vertical plane, and the top view will be projected on the horizontal plane. Keeping the vertical plane stationary, rotate the horizontal plane in the clockwise direction and make align with the vertical plane, so that the two images will lie in a single plane. This line, which is called reference line, differentiate the horizontal plane with the vertical plane. So I think now all of you have understood the concept or the basic introduction about the projections which is used in engineering graphics. In the next video, we will study how to project the points or the projection of points in engineering graphics. Once you learn how to project points, then you can easily understand what actually the projection is. So I hope all of you have understood. We will see in the next video with the projection of points. Thank you.